Differential equations, chapter 4. So in the second order differential equation, so we will cover the topic of homogeneous linear equation and non-homogeneous linear equation. So for the second order homogeneous differential equation, it is to be said homogeneous when the given second order linear equation is equal to 0. Okay, so what is the step to solve? The step to solve the second order homogeneous linear equation is, the first one, we need to find the characteristic of the equation or auxiliary equation by let our d square y over dx square is equal to m square. Okay, second, we make our dy dx is equal to m, and the third one is our y equal to m power of 0 and is equal to 1. So in order to solve the auxiliary equation, we need to determine the three types of the roots. Depends on the first one. If we have b squared minus 4ac is greater than 0, so we state that this type of root is real and distinct, where our m1 is not equal to m2. And the general solution, we can come out with y equal to a e power of m1x plus b e power of m2x. And for the second case, when we have b squared minus 4ac is equal to 0, then the case 2 is the real and equal m1 equal to m2. And the general solution, y equal to m power of 1x multiply with a plus bx. And the third one is discriminant, where b squared minus 4ac is less than 0. So for the case 2, conjugate complex roots, which is m equal to alpha plus bi. So for y equal to e power of alpha x, we factorize the a cos beta x plus b sin beta x. So let me try to solve this formula, this question. Okay, so we are given question 1. Solve the following differential equation where our 2y square, okay, y double prime minus with 5y minus 3y equal to 0. So for the solution, what we need to do is we change first the value of double prime here with m. Okay, let our y is equal to m. Then what happen is our y become 2m square minus 5m minus 3 is equal to 0. Okay, let y equal to y double prime. Y prime is equal to m. Y double prime is equal to m double prime. Okay, so now our equation, we can factorize this equation. We will get 2m plus 1 multiply with m minus 3 is equal to 0. Then from here we will get our m is equal to negative 1 over 2, and another one is our m equal to 3. Okay, so this is the real and district. Okay, for step number 1, this is the first step. For the second step is we need to change the general solution. So for the general solution is y equal to a e power of negative 1 over 2x plus b e power of 3x. So this is the solution for general solution. Okay, let me look at example 2. Solve the following differential equation of d square y over dx square. plus 8 dy dx plus 16y equal to 0. So for auxiliary equation, okay, we can do m square plus 8m plus 16 is equal to 0. Then we can factorize here. Okay, we factorize this equation, we will get m plus 4 and m plus 4 also. Then from here we will get our m is equal to -4. Then the general solution is y equal to ae power of -4x plus bx e power of -4x. Okay, next, solve the following of differential equation. Okay, so d square y is m square plus with 4m plus with 6 is equal to 0. Okay, so from here we factorize our m, we will get m plus 2 square. Then we solve, we will get our m is equal to -2 plus minus square root of -2. Okay, so we get -2 plus minus square root of 2i, where I is the conjugate complex root. Okay, I is the conjugate complex root. Okay, so our general solution for this case is y equal to e power of -2x multiply with a cos square root of 2x plus dengan b square root of 2x. Okay, so next we want to solve the initial problem for y 2y square. So we put here 2m square plus 5m minus 3 is equal to 0. Then we will get our m is equal to 1/2 and -3. Okay, therefore we will get yx is equal to ae power of 1/2x. Okay, plus with be power of -3x. Then we solve y0 is equal to 1. Okay, because of it's already given to us. When our y0 is equal to 1, means a plus b also equal to 1. Okay, then from here we come up with the general solution, which is y prime equal to 1/2 ae power of 1/2x minus 3 be power of -3x. So this is the example for homogeneous differential, second order homogeneous differential equation.